Hey guys, welcome back to another tutorial. Not really a tutorial, but a video. And in this video I'm going to be explaining or showing you guys a practical demo of orthographic projection. So in the previous tutorial in this 3D projection series, I showed you guys a quick PowerPoint on the basics, and in particular I showed you guys these 5 steps which I think of as orthographic projection. So here I actually have a project I made a few months ago, and it's basically my own 3D engine. So I've called it Aria 3D because, you know, just had to name it something. But yeah, basically in this one file here, the main source file, I basically incorporated all these steps plus a bit more, but I'll try and explain what's going on. So first of all, we need to get the object data. I'm going to be showing you guys how this 3D engine actually gets the data, then renders it to this. Now if we look at the top part of this file, it's mainly just canvas utilities, so I'm just creating a bunch of functions which allow me to easily draw things to the canvas without having to worry about the JavaScript coordinate system. So you can see I'm just using regular XY coordinates, and yeah, that's what this first part is. Then what I did was I created some math utilities, so just, you know, vectors, Eulers, like angles, and yeah, just made a matrix class so I can do this, things like this. Ignore this misspelling of multiply matrices. Now I know now it should actually be multiply matrices, but you know, just a minor error. And then I have a bunch more maths things, just things that I want to that is useful to abstract in a function. But one thing I actually want to show you guys is, if I go here, if we look at this function in particular, the calculate rotation matrix. So I recommend watching the first video of this series if you haven't already, but in that first video I talk about the rotation matrix formula. Basically all it is it allows you to convert a bunch of rotations and angles in the X, Y and Z directions or axes, and it just gives you it in a matrix form so that you can just multiply that matrix by another matrix to get those rotated points. So this function takes in the rotations in the 3 axes, then it just calculates them, mods by 360 because so it can actually get the actual rotation, and then it calculates the I hats, J hats and K hats, which basically correspond to each row of the each row of the rotation matrix. So you can see we're calculating all of this, and we're just doing all of the necessary calculations. This is all just in the formula which I described in a video yesterday, and then finally we just create the rotation matrix and return this matrix. So now I'll show you what I mean by get the object data. If I scroll a bit more down, you can see we actually have a class for the shape. What this is going to contain a point matrix. So for example, for a cube, this would literally just be the points in space when it's centered, not rotated at all. Then it also contains its rotation data. Ignore the quaternions, just focus on this for now. And the physical matrix is how it's being rotated, so that's this step. So what I do is I get this step and this step, get object data and rotate object. All of that data is encapsulated inside the shape class. So when it says update a physical matrix, you'll see what it does is it creates this physical matrix, and it's just going to get the points in the point matrix, rotate them using the quaternions. You don't need to know too much about quaternions right now, but yeah, just imagine this as being used in the rotation matrix. Then it just rotates it and it adds it to the physical matrix. So the point matrix is going to be the object data in this form, then the physical matrix is going to be the object data in this form, both of which are just the object at the center, the origin, but now the physical matrix has rotated the object. So we've actually done the first 2 steps of this. Now I can actually scroll down and we finally get into the camera part. So I have the base camera class, there's nothing much here, but if we scroll down to the absolute camera, which is what my orthographic camera is, you can see we have our points. So when the render function is called, let's imagine we're passing our cube shape. First it's going to do is it's just going to go through all the objects. See, this is an array, so if we go here, first it's going to get the camera points, which is going to copy the physical matrix. So the physical matrix, if you remember, was this stage. It's going to take those and it's going to translate it by the object's position. So that is this step here. then it's going to pass them into this transform points function, which is just above here, and you can see we translate the matrix, which is equivalent to this step here. Then we rotate it using the world rotation matrix. If I go up, you can see that we're using that calculate rotation matrix thing from earlier, and it's just rotating these camera points so that we finally get this. Then these other two steps are quite simple. Translate for ABS position, well, that's just going to add a vector, an XY vector, so absolute position is literally just moving it to the left or right. We're not moving anything in 3D space anymore. And finally we just scale it for the zoom of the camera, and that's basically it. Then the rest of this function is really just creating it, putting it in some kind of form, then rendering it. If you see this render function, this is literally just to draw the faces and objects in the correct order, and then it's just going to check if it's outlined and things like that, simple things like that. So this is the main thing which we want, the transform points function, as well as the rotation using the object's point and physical matrix from in the class shape. Now I'm going to show you guys an actual demonstration. So we've seen the code for it, now I'm going to show you guys the actual demonstration. So this is the 3D engine, it's the same thing. It's on my GitHub if you want to have a look at it, but I'm just going to scroll down, and I've actually made a demo of this. So if we go here, this is my demo for the orthographic projection. It's pretty simple, but if you notice, this triangular prism doesn't actually change size as I rotate it around, which is how you can tell it's orthographic, not perspective. But yeah, you can see this code being used in action over here. So yeah, you can see the scale being applied as we scroll in. And what I meant by the translate for absolute position is if I hold Alt, you can see I'm literally just moving the entire screen left and right. I'm not really moving in 3D space, although it might look like that. I'm actually just like moving things around like this. So yeah, thanks for watching. This was my demonstration of orthographic projection. In the next tutorial, I'm going to be giving you a visual demonstration of perspective projection. So make sure you stay tuned for that, and then in the coming videos I'm going to be doing something else. Maybe I could even be making a new 3D engine just so you guys can see the process. But thanks for watching, and I'll see you guys in a future tutorial. Bye.